Good afternoon, dear students. Today we are going to see for each case how to determine the moment of force about a particular point. So if we take the first figure, case A. Now that it's a simply supported beam, it is fixed at one end. Other end, force of 100 Newton is going to act. Now you want to determine the moment of this 100 Newton force about the point O. Now, how will you determine the moment of the force about the point O? Now, moment of the force is equal to force into perpendicular distance. So, what is the magnitude of the force 100 Newton into the perpendicular distance is 2 meters. That is from point O, where the application of force is there, the distance is 2 meters. The perpendicular distance is 2 meters. So, 100 into 2. 100 into 2 is 200 Newton. Now we have to determine whether it's a clockwise or anti-clockwise moment. So it is going to rotate this force is going to rotate this particular body in the clockwise direction. So clockwise is considered as negative. So it is taken as minus 200 Newton meter. So this is the answer for the first figure. Now next we go to the next figure. Now the moment of the force 50 Newton about point O you have to determine. Now the 50 Newton force is acting in this direction. Now the moment of this force about the point O. Now this force as per principle of transmissibility, force can be transferred to any point along its line of action. So for a 50 Newton force, you can transfer this force to any point on its line of action. So if you bring this force here, now the force into the perpendicular distance. So 50 Newton into the perpendicular distance, it's going to be 0.75. So 50 into 0.75 is going to be the moment of the 50 Newton force about point O. So what is the actual moment of this force? 37.5 Newton meter is going to be the answer for the case B problem. Now if you go and take case C, now here you have to determine the moment of the 7 kilonewton force about point O. Now again, applying the principle of transmissibility, the force can be transferred to any point along its line of action. So the 7 kilonewton force is transferred along its line of action. From here, the perpendicular distance is going to be 3 meters. So this distance is 1 meter and this distance is going to be 4. Total distance is 4 meters. So this is going to be 3 meters. So force into perpendicular distance 7 into 3, that is 21 kilonewton meter is the answer for this particular problem. So similar manner for this case D, you can resolve this force into two components. That is 60 kilonewton along the horizontal direction and 60 kilonewton along the vertical direction. So for 60 kilonewton along horizontal direction, it is going to be 60 sine 45, and this is going to be 60 cos 45. Now for 60 sine 45, for 60 cos 45, it is going to be 60 cos 45 into 1, and for this 60 sine 45 into it is 3. So the sum of these two gives the moment of the force about the point O. So in this way, you can determine the moment of the forces applied at various points along the body.